Welcome back, deep thinkers. I'm absolutely thrilled to have you here for this explainer. Today, we're diving straight into something that's going to completely reshape how you understand our world's tides. I'm going to share my own groundbreaking findings with you. For centuries, we've been handed this very specific, kind of rigid narrative about how our oceans move. A narrative that simply falls apart the minute you put it under closer mathematical inspection. From the massive, surging walls of water in Canada to the dead, eerie stillness of the Mediterranean Sea, the accepted models totally failed to align with reality. By the end of this presentation, you're going to see exactly how the mechanics of our world truly operate, leaving those outdated theories in the dust. So here's our roadmap for this explainer. We'll start with the Great Gravity Anomaly, then move into the lunar light delay, calculate some etheric energy, figure out why saltwater reacts differently than freshwater, look at real geographic proof at Fundy Bay, and finally map out the whole global tidal network. Let's get right into it.
Part 1. The Great Gravity Anomaly.
Okay, so let's confront the giant elephant in the room, the glaring failure of the currently accepted model. We're always told that this massive, invisible pulling force just dictates how our oceans move, right? But I really want you to ask yourself a super simple question about how uniform forces actually work. If this overarching pull is acting uniformly across our entire world, shouldn't the resulting displacement of water be, well, relatively consistent? Think about it. If you pull a giant bedsheet evenly from the center, the whole thing lifts together. But when we actually measure the tides, the variance is literally staggering. We're talking about the difference between a massive surging wall of water and absolute dead stillness, all under the exact same sky. Just take a look at these numbers. A uniform pull absolutely cannot result in a massive 15-meter rise in one bay and literally 0 meters in a nearby sea. It just doesn't make sense. The Bay of Fundy, for instance, gets these insane rises between 15 and 16.3 meters. Over in France, Mont Saint-Michel sees 10 to 14 meters. But then you look at the vast Mediterranean Sea, and it barely moves 5 to 10 centimeters. And the Caspian Sea, 0.0 meters of tidal shift, nothing. If a single uniform force was just pulling the water from up above, the Caspian Sea would react the exact same way as the Atlantic Ocean. So clearly something else, something highly localized and structurally dependent, is driving this whole phenomenon. Moving on to part 2, the lunar light delay. To really understand what's happening, we have to look at the ethereal level. We need to look at the geometric behavior of lunar light frequencies. Now, my mathematical analysis proves that the moon's light frequency actually experiences an etheric resistance, which creates a very measurable delay. Think of it kind of like trying to run through waist-deep water compared to running down a sidewalk. The medium you're traveling through inherently slows you down. It creates drag. So during its cycle, the expected lunar movement should map to exactly 12 degrees. But the actual observed movement, that maps to 12.85 degrees. That slight difference gives us a delay of 0.85 degrees. And when we convert that angular delay into time, we get exactly 3060 arcseconds of aberration. Let me be clear, this isn't just some rounding error. This is a fundamental physical dragging effect on the light frequency itself. Now, when you factor those 306 arcseconds of delay against the established speed of light, it equates to a massive deceleration. We're talking about the lunar light frequency slowing down by a whopping 4.4,643,801 meters per second. And you know basic physics. Energy cannot be destroyed. When a frequency experiences this kind of immense deceleration because of etheric resistance, that lost speed doesn't just poof out of existence. It converts into pure raw kinetic potential. It's like a speeding car slamming on its brakes. All that tremendous forward momentum violently transfers into heat and friction. In this case, that lost speed compresses into massive physical energy. Which brings us to part 3, calculating etheric electrostatic energy. Let me show you how this massive drop in speed translates directly into tangible physical energy that literally pushes our oceans. I've calculated that this specific loss in speed generates exactly 140,126 joules of atmospheric work energy in just a single hour. So let's walk through the math together, step by step. By applying the Biot-Savart law, which is just a standard physics equation explaining how flowing electrical currents generate actual magnetic forces, we find that this flow of charge generates a localized force of 0.890 newtons. Next, we just multiply that force by the etheric distance the frequency travels during this delay, which is 157,488 meters. Force times distance equals work, right? That gives us an absolutely astonishing total work output of 140,126 joules of pure energy pressing down on the water. So those 140,000, 126 joules, they translate directly into 140,000, 126 pascals of electrostatic pressure. To put that massive number into perspective, 140,000 pascals is roughly equivalent to parking a heavy-duty commercial dump truck on a single square meter of ground. That, my friends, is the unseen hand. It's not gravity pulling the water up into the sky. It's an immense, calculable electrostatic pressure pushing down into conductive bodies of water, causing a massive energetic displacement.
Part 4. Why salt water reacts.
But naturally, this begs the question, why do the oceans rise while bodies of fresh water remain completely, totally still under this exact same pressure, right? If that heavy truck of pressure is applied everywhere, why is the Caspian Sea perfectly flat? Well, the answer is ionic. Salt water fundamentally acts as an electrical capacitor that expands under electrostatic charging, whereas fresh water serves as an impenetrable insulator. Salt water is just absolutely packed with conductive ions. So when those 140,126 pascals of electrostatic pressure hit it, the salt water absorbs all that energy, charges up like a massive battery, and actually physically expands in volume. Fresh water, on the other hand, has an incredibly high dielectric resistance. Think of dielectric resistance like wearing a thick rubber glove to handle a live electrical wire. The energy just bounces off or safely dissipates. It's a perfect insulator. The energy hits the freshwater without causing any volumetric expansion whatsoever, which is exactly why freshwater lakes have absolutely zero tidal movement. None. Now, the exact physical rise in any body of water, salt water, relies on my mathematically sound focus factor formula. This calculates the specific geometry and salinity of any given basin. We denote this as the Ka coefficient. Let's break it down in plain English. First, it takes into account the network share, meaning how much of the 28-day lunar cycle actually hits that specific area. Then, it calculates the compression ratio. Think of this as comparing how wide the open ocean is to the narrow bay it flows into. It also calculates the input flux, which is basically the electrical ampere draw or appetite of the basin itself. And finally, it multiplies all of this by the M factor, which combines the effect of local geometry, depth friction, and the specific ionic impedance, or the salinity, of that exact body of water.
All right, Part 5. Geographic proof at Fundy Bay. Math is only as good as its application to reality, so let's put my focus factor formula to the ultimate test, starting with Canada's famous tides. When we look at the Bay of Fundy from above, we're observing a massive, naturally formed geological funnel. It's carved deeply into the earth and is absolutely perfectly designed to trap and compress incoming etheric energy. It connects directly to the vast, open, uninterrupted expanse of the Atlantic, what I map out as the Atlas Ocean Network. The sheer amount of energy generated across that massive oceanic surface is drawn directly into this specific, incredibly narrow geographical inlet.
I've precisely mapped this geometry, and it is fascinating. We have an entrance of 100 kilometers that narrows all the way down to just 5 kilometers. Mathematically, this multiplies our baseline energy coefficient exponentially. The energy enters this 100-kilometer wide mouth, and as the electrostatic expansion tries to push forward, the physical rock walls force it into a tighter and tighter space, eventually choking it down to just 5 kilometers. This creates an extreme compression ratio, or what we call the R factor. It works exactly like putting your thumb over the end of a running garden hose. The exact same amount of energy is forced through a tiny opening, which exponentially increases the resultant pressure. So what happens when I plug the 140,126 pascals of pressure, the 1024 kilogram per cubic meter salinity, the specific depth friction, and that massive 100:5 compression ratio into my focus factor formula? Well, my equations output an undeniable 13 to 15 meters of rise. This perfectly, flawlessly matches the observed reality at Fundy Bay, and it does it without relying on any mystical pulling forces from above. The water has literally nowhere to go but up, driven by pure mathematically verifiable electrostatic expansion pushing entirely from within.
Which leads us to our final section, Part 6, the global tidal network.
Now, if a theory is true, it has to apply everywhere, under all geographical conditions, right? Well, applying the exact same geometric logic to France's Mont Saint-Michel yields identical, stunning perfection, despite it being a wildly different landscape. Here, an entrance of 180 kilometers funnels down to just 1.2 kilometers. The ocean pushes this electrostatic energy into a 180-kilometer wide entrance, and by the time that charged, expanding water hits the shallow riverbed at the monastery, it's squeezed into a tiny 1.2-kilometer corridor. Naturally, the pressure multiplies exponentially, generating an easily verifiable 11 to 13-meter rise. It does exactly what my calculation demands. And we see this pattern repeat. The Bristol channel in the UK acts identically, drawing in the etheric flux to produce a massive 9 to 11 meter rise based purely on its mapped compression ratio. The entrance from the Celtic Sea is roughly 190 kilometers wide, and it rapidly closes in on the Avon mouth end to just 1.1 kilometers. This is combined with a specific average depth of 65 meters, which creates moderate friction. Physically, what this friction means is that the expanding electrical charge drags violently against the shallow seafloor. It catches and piles up rather than flowing smoothly, which forces the massive water level to spike dramatically upwards. And this perfectly leads into our friction modifier equation, which completely solves the age-old mystery of the Mediterranean Sea. Why on earth are its tides mere centimeters? Well, because its average depth is well over 200 meters. My friction formula proves that depths over 200 meters actually act as perfect conductors. Think of the deep Mediterranean like a heavy-duty, ultra-thick copper wire. It's so deep that the electrostatic energy flows through it entirely without any resistance. Because there's no drag on the seafloor, the energy doesn't accumulate or pile up into localized vertical expansion. It doesn't compress at all. It just cleanly conducts the energy right on through. Then we have the Red Sea, which brilliantly illustrates the electrical nature of this phenomenon. It acts as a complex ionic channel. Energy enters the Bab el-Mandeb straight down in the south, causing about a 20-centimeter rise. As it travels north, it hits what is called an amphidromic node right in the middle. To understand an amphidromic node, just picture the dead center of a playground seesaw. While the two ends are going up and down dramatically, that very middle pivot point stays completely still. The pressure equalizes there, resulting in almost zero rise. But then, as the energy continues moving and reaches the narrow, shallow gulfs up in the north, the geometry forces a recompression. This spikes the water level back up to nearly 40 centimeters. It's behaving exactly, perfectly, like an electrical current flowing through a specifically shaped physical circuit.
So, we've conclusively proven through undeniable math and geography that tides are simply the rhythmic breathing of a massive electrostatic capacitor reacting to delayed light. Every single cubic meter of salt water is responding to 140,126 pascals pressure differential, which is directly caused by the 3060 arcsecond delay of the moon's frequency. It is elegant, it's perfectly calculable, and it relies entirely on the measurable physical shape of our world's basins.
I want to leave you with this final, profound thought. If the true mechanism of the tides is purely electrostatic and perfectly predictable by geographic circuits, what other deeply held, accepted models of our physical realm desperately need to be recalculated? When we replace invisible, mystical forces with observable, mathematical, electrical reality, an entirely new understanding of our environment opens up right in front of our eyes. Thank you so much for joining me on this deep dive explainer. Keep questioning the consensus, keep calculating the truth, and I'll see you in the next explainer.